Well, welcome to video circles number 12. So this is our 12th video, and we are looking this time at section 10.6 in your textbook. The topics we're going to cover are secants, tangents, and angle measures. So we know something about angle measures and tangents. So the real question we have is, what is a secant? Well, a secant is a line that is actually drawn all the way through a circle. Remember, a chord is a line segment, but a secant is a line that goes all the way through the circle and always crosses the circle in 2 points. A tangent only crossed the circle in 1 point. A chord touches in 2 points, but it's not a line. So that's the difference between a secant, a tangent, and a chord, and that's important to remember. And so let's take a look at this diagram. What we have is a circle with 2 secant lines drawn through it, and the secant lines intersect in the middle of the circle somewhere at point P. Now notice, P doesn't have to be in the center of the circle. It can be anywhere on the inside of the circle. And also what I've done is I've labeled a couple angles. Angle APB is angle 1, and angle BPC is angle 2. And so what we're going to talk about is we're going to talk about the theorem in this section that is important to know. And it is a way to find angle measures. Okay? Now, before we have learned central angles equal their intercepted arc. Inscribed angles are half the intercepted arc. So what would these angles in the middle formed by 2 secants, or if you wish, the chords that are part of the secant, what would those angles be equal to? Well, it turns out that the measure of angle 1 is equal to the sum of the measure of arc AB plus the measure of arc DC times 1/2. And the way we say it is the measure of angle 1 equals 1/2 the measure of the sum of the intercepted arcs. And so AB and DC would be the intercepted arcs for angle 1. So what I want you to do is pause the video, and I want you to write this formula, but do it for angle 2 this time, the measure of angle 2, and see if you can write it out. So here I am again. So what did you write? The measure of angle 2 is equal to 1/2 the sum of its intercepted arcs. So what are the intercepted arcs for angle 2? They are arc AD and the measure of arc BC. And so if you take 1/2 the measure of the sum of the arcs, then that is going to be the measure of angle 2. Next slides are going to do a few examples of this. So here's an example of how this 2 secants intersecting in the middle of a circle theorem can help us find the measure of an unknown. As you see, I have a circle here. I have secant DB intersecting secant AC at point Z here in the middle, and I can see that this angle at Z is equal to 110 degrees, and I can see arc DC is 97 and arc AB is X, and what I want to do is find X. So because these are 2 secants intersecting, I know that the measure of angle Z, or if you wish AZB, has to equal 1/2 the measure of the intercepted arcs AB plus the measure of arc DC. And so I know that. So all I do is I fill things in. Well, as I can see, the measure of angle AZB is 110. And then I put 1/2, and the measure of arc AB is X, and the measure of arc DC is 97. And so what's that leave me? That leaves me a little algebraic equation to solve. And so what I like to do is I like to get rid of the fraction. So I'm going to multiply by 2 on both sides of the equation. So I get 220 equals just X plus 97, because 2 times 1/2 is 1. Subtract the 97, and that gives me X. So that will give me 123 degrees for the measure of arc AB, which is what X is. And that's an example problem, and I'll probably have a couple others later on here. So the next theorem that we're going to do here in this section also helps us find angles, and these are angles that are made when a secant, which is AB, intersects with a tangent at the point of tangency, in this case point A. And notice that makes two angles, angle 1 and angle 2. Alright? And so this theorem is going to tell us what the measures of angle 1 and angle 2 are. So alright, the measure of angle 1 equals, well, what does it equal? According to the theorem, it is half the measure of its arc. So notice where the angle is, there will be an arc there, and so the arc that is in the angle is what you're equal to. And then the measure of angle 2 is also going to be half of its arc, but angle 2's arc is this one, because that's the one that's inside the angle. So the measure of arc ACB. And that's the theorem, and so we'll show you a simple application and do some problems. So here's a simple application of that theorem. What we can see in the diagram is KL is a tangent line at point K, and JK is a secant line that crosses at K, and so we can see that we meet the conditions of the theorem. If a secant line intersects a tangent line at the point where it's tangent, then the measure of the intercepted arcs is half the measure, the measure of the angle is half the measure of the intercepted arc. And so therefore the measure of angle 1 has to equal 1/2 of 194 degrees in our diagram. So the measure of angle 1 is equal to 97 degrees. Can you find the measure of angle 2? Why don't you give it a shot? So now I'm back, and measure of angle 2, well, first I need to find the measure of this arc. Well, what's that going to be? Well, it's going to be 360 minus 194, which is equal to 166 degrees. And so since that measure, the arc is 166, the measure of angle 2 is 1/2 166 degrees, which is 83 degrees. And so now we found the measures of both arcs. So here's a couple of quick problems, the one on the left and the one on the right, and I would like you to take a shot at solving them and then come back and do the video and see how you did. So pause now. Okay, now that you're back, let's go ahead and do these problems. So how do you find the measure of angle 1? Well, there are two secants. Therefore, I know the theorem says that the measure of the angle is equal to 1/2 the sum of the measures of the intercepted arcs. So the measure of angle 1 equals 134 plus 86, and then we want to multiply that times 1/2. And that's equal to 140, 220 times 1/2. So the measure of angle 1 is 110 degrees. Now I went ahead and put the measure of angle 2 up here. And I can think of several ways to get the measure of angle 2. So let's do the easy way. The easy way is, well, angle 2 is supplementary to angle 1. Therefore, it's 180 minus 110. And that's correct. And that gives you 70. But there's another way to do it. And the other way to do it is, because it's in a circle, you might think you have to do it a circle way. And so in that case, you would go, well, I don't know the measure of arc BA and CD. They didn't tell me. But what I do know is what they add to. Why? Well, because the other two arcs add to 220, that means there's only 140 degrees left, and the measure of angle 2 is half of that, half the sum of the measures, so it's equal to 70 degrees. And now you can see we can do it in two different ways to find that angle, neither one of which is very hard. So how about the problem over here on the right? What would you like to do to solve that? To find the measure of angle 3, that is a secant line that crosses at the tangent point of a tangent line. Therefore, angle 3, the measure of angle 3 is equal to 1/2 the measure of its intercepted arc. So half of 146 is 73 degrees. So that's it for the video. You've now seen the basic problems, and then we can go from there and see how you do. Alright, tomorrow we start 10-6. See ya.